at any time. And then please if inform me if the audio or my visual are not clear. And then please turn off your mic and also your camera. Unless you have any question, you can switch on your camera or your uh, mic. Okay, for today, I hope please refer to UKM Folio to download this course material. Okay, for topic 5, there is about limit and continuity. Basically, this topic is a continue from the topic 1. In topic 1, we have learned about, I explained about the function, the linear function, and quadratic, log, and exponent, and the application as well. Okay. Okay. If you for topic 4, basically topic 4 is optional for the title for topic 4 is algebra method. This is optional for topic 1. For this semester, for this set, I decide I will not cover that topic, and then I will skip the topic 4 in our syllabus for this semester only. So in other words, there is no question for mid test from topic 4. The mid test only cover topic 1, topic 2, and topic 3, which is we have just finished topic 3 yesterday. Okay. What is the topic 5? Okay, topic 5 is about a limit and continuity. Or in bahasa Melayu we call it as a limit is had dan keselanjaran. Had dan keselanjaran. Had dan keselanjaran. The concept of limit and continuity. Okay, what is limit? So the first part of this lecture today, I will explain about the limit, how to find limit, how to determine limit based on the equation. Okay. Basically, limit. What is limit? In finding a limit, the value considered is the value approached by x. Limit meaning that we need to determine, we need to know what is the value approached by x when the in other words, that when x approach one point, when x approach a point of A, we want to know what happened to y. What happened to the y is, I hope you still remember the relationship between y and x. We have y, for example, for linear, y equal to mx plus y equal to mx plus c, where we have y is dependent, x is independent variable, x is input, y is output, and then the set of x is called domain. Meanwhile, the set of y is called range or julat. In order to find y, we need to know x first. We need to determine the value of x. That's why in this concept, in this topic, limit and continuity, especially in terms of limit, what we would like to we want to find what happened to y when x approach certain value. For example, when x approach 10, what happened to the function? What is the value that what is the value will approach by the fx or y in term of limit. That's why if you refer to this definition, the value the limit is referred to the value considered. The value considered is the value approached by x. That is the value of fx as x approach a point of A, rather than the value of fx when x equal A. We are not interested what is the value of y when x equal A. We want to know what happened to y. What is the value of y when x approach mendekati, menghampiri certain points, satu nombor. So if a function fx is defined for all x, in other words, we can x is domain for y. If a function of fx is defined for all x near A, menghampiri A, berhampiran dengan A, but not necessarily at A. It's not about D point A tersebut. We want to know nilai X yang hampir, bukan nilai X yang pada, nilai X pada satu nilai. X near A, but not necessarily at A, and Fx can be made arbitrarily close to L for all value of X near A. That's quite confusing. We need to find the value that close to A, but not equal to A. The limit of the function is L as X approach A. Okay, in mathematics, we have this notation or this equation. We have LIM. LIM is limit, a short form of limit of Fx when, okay, the limit of Fx when X approach A. This sign X approach A. X menghampiri A is one number. The limit is equal to L. S is the value of limit. So this notation is can be read as the limit of function Fx as X approach A is L. Okay. Then the definition or the meaning of the notation, how to read this notation. Again, this notation LIM Fx X over A equal L, meaning that the limit of Fx when X approach A is equal L. Had bagi fungsi X apabila X menghampiri A ialah L in bahasa Melayu. For example, I will refer to the linear function y equal to 2x minus 1 or y equal to 2x minus 1. Now, based on topic 1, okay, based on topic 1, when y equals 2x or Fx equal to 2x minus 1, for example, for this equation, let's say at point when x equal 2, for example, when x equal 2, the range, the value of y is 2 times 2 minus 1 equal 4 minus 1 equal 3. That we learn in topic 1. Based on topic 1, we know that the value of y when x equal 2 is 4 based on this linear equation 2x minus 1. Okay, that's F2 when in topic 1. But in this topic, when we want to find a limit, let's say I choose one number. Let's say x equal a. I want to analyze when x close to this number. When x close to, when x approach 2. When we're talking about when x approach 2, let's say we can draw this number. This is x. When x approach 2, x can come from the left of 2 or from the right of this number. In other words, when we say when x approach 2, x can approach from the left, from the area of x less than 2, or from the right, from the area x greater than 2. And then, as you can see here, there is if you refer to this top, there are two tables here. I share with I show these two tables show that what happened to the fx, the value of y, when x approach 2 from the left, 1 point, when x equal to 1.7, 1.8, 1.9, 1.9, 1.9999, and so on. When x approach 2, when x approach 2 from the left, So how to find the value of y? I just substitute x equal 1, x equal 1.7 in the in equation. We just find what the value where fx equal to 2x minus 1. We just replace x equal to 1.7, y we equal to 2.4. When x equal 1.8, y equal to 2.6. When x equal 1.9, x equal 2.8. When x equal 1.999, x equal to 2.998. Okay, for the example, this simulation show that when x approach 3, when the x approach 2, the value of x increase and close to 2. X approach 2, not x equal to. What happened to the y? As you can see here, the value of y will increase, but close to 3. Based on this simulation, based on this first table, so we can conclude that when x approach 2 from the left, the fx approach 3. And then now I will analyze what happened to fx when x approach 2, but now from the right. From the right means that the value of x must be greater than 2. Let's say I choose this number. I start with you can start with 3, 2.9, 2.8, 2.7, 2.6, 2.4, and so on. I start with 2.3. As you can see here, when x equal 2.3, what happened to y? Y is 3.6. Now, when x equal, when x come closer to 2, now 2.2, fx equal 3.4. When x 2.1, y 3.2, x 2.02, y 3.002, and when x 2.002, y equal to 3.0002. And then you can continue this process. Let's say y.00001. What happened to x? X will close to 3. Y will close to 3 at 3.0000, and maybe 0.0002. The value of y close to 3. Okay, that this simulation show that what happened to fx when x approach 2. For this example, we can conclude that when x approach 2 from the right, the value of y approach 3. So based on this two examples, when x approach one number, in this case, I choose x equal to. You can choose any number. You can see you can check what happened to y when x approach 10, for example, from the left, from the right. You just replace the number, and then you can see y will approach certain number. Okay, that's the concept of limit. So in general, we can say that based on this example, the value of 3 is the limit of fx when x approach 2, either from the left or from the right. The value of y. Our focus now is on y. What happened to y? What happened to y or fx when x approach certain number? So based on this example, we can conclude that the value of y will approach to 2. Will approach 3. 3 is the limit for the function when x approach, when the input or dependent variable, independent variable approach 2. Thus, the limit for the function, we can say that the limit for the function, therefore, the limit for the function fx when x approach 2 is 3. 3 is the limit of the function, or we can write the conclusion. We can simplify the equation like this. We just write lim, and then we put here x error 2 or x approach 2 for the function 2x minus 1 is 3. The limit of the function is 3. When x approach 2, based on this equation, based on this notation, is when x approach 2, whether from the left or from the right, the function of 2x minus 1 will approach 3. So 3 is the limit of the function. 3 is the value of the limit. That's the basic concept of the limit. Okay. If you have any question, you can just ask your question, turn on your mind and ask the question. Okay, this example is based on the table. Okay, we can draw this equation. You can refer figure graph of figure 5.1. This is a linear function. Okay, this is a linear function. In topic 1, we write y equal to 2x minus 1. I hope you still remember. M equal 2, C equal -1. And then when we draw this the graph, the line is rise from the left to the right, which is the intersection point at y is a -1. It's a -1. And then for example, I choose one number, one value of x. Let's say x equal 2. X equal 2. When x equal 2, we know that y equal 3. Okay, that's this point, this coordinate point, we have 2 and 3. Okay, now based on this table, now I explain the same concept, the same limit, the same function, but now by graph, by using the graph. When we're talking about the limit, when x approach 2 from the left, they come from this area, from the right. From the when x approach 2 from the left, what happened to y? The value of y will move along this line, along this function, along this linear line, and the value of y will approach 3. And the value of y will approach 3. Same when x approach 2 from the left, from the right, what happened to y? Y will approach 3. Based on this. Okay. Now, in other words, in terms of limit, in order to determine what is the limit, we need to know the what happened to the y when x approach a certain number from the left, and then from the right. For the example, we know that the value of y is the limit is 3. The limit of the function is 3. The limit of the function is 3 when x approach 2. Whether it doesn't matter the x approach from the left or from the right. That's the concept of limit. And then okay, there is another explanation. There is a two figure. If you refer to figure 5.2a and b, 5.2a and b here, there is two graph here. In this graph, this graph is from this graph, the graph will explain about what is the difference between the limit and the value of the value of y. The limit of y, the limit for the y, and the value of y. So based on this graph, they are 5.2a and 5.2b. There are also explanation about the graph. You can refer to figure 2, page 2 and page 3. Okay, based on figure A, 5.2a, and then we have one point here. We have one point. There's what we call it a black hole, a black point here, the solid black dot here. Okay, this and then our focus in when x equal 4. Okay, let's say when x equal 4, y equals 6. Okay, this function, the value of x is 6. The value of x is 6 when x equal 4. That's why we can write f in bracket 4 equals 6, meaning that this equation what we call it, refer to the function value. The solid black dot, you can see here the solid black dot at the coordinate of 4 and 6 indicate that the function is defined exactly at x equal 4 with a value of f4 equals 6. So the function is defined when x equal 4. We can find the value of x. So we can find the value of y when x equal 4. So that's why we need to find in terms of coordinate, we can draw the solid black dot point as you can see, like in figure B. And then when x in terms of limit, okay, now we want to explain this graph in terms of limit. This notation say that the limit of fx when x approach 4 is also 6. When we're talking about the limit, we want to know what happened to the function when x approach 4, whether from the right or from the left. Okay, based on the graph, we just check the line, and then when x approach 4 from the right, what happened to y? Y will approach one number along the y. We follow the value of y. We follow the line, the value of y. And then when x approach, as you can see here, when x approach 4 from the right, based on this line, the value of y will approach 6. And then when x approach x from the left, what happened to y? Y, this is the value of y along the line. The value of y also approach 6. So in this case, we know that when the x approach 4, whether from the left or from the right, the limit of the function is 6. The value of y will close to 6, or will approach y approach 6. So we can see here the limit of the fx when x approach 4 is 6. 6 is the limit of the function. Okay, that is the graph B A. Okay, now we can I see now we move to the we proceed to the graph B. Okay, graph B show that the same function, but now we have two dot here. The black dot and the white the black dot and the white dot here. We have a whole there are 2 points here. For example, I just label it as A and B, point A and point B, Okay, the black dot. What is the difference between the black dot and the white dot? The black dot is represent the value of y. The function is defined at that point, at black dot point. For this case, at point A, the value of y is defined at point A, not B, because the B is there is 1 point. B represent the white dot here. The white dot the white point here show that, meaning that the value of y is not defined. The value of y tidak tertarif. In Malay, or in other words, we can say that the value of y tidak wujud pada B. The value of y wujud pada A. So in other words, if we want to identify the value of y in terms of dot or coordinate point, we need to find the black dot, not the white dot. Basically, we can say that that is the difference between the black dot and the white dot. Okay, now I would like to explain in terms of the value of the function and the limit and the limit of the function. Okay, let's say now we assume the same question, the same line here, but and then the same value of x. Now we want to know when x equal 4. When x equal 4, okay, this one. When x f in bracket 4 means that when x equal 4, what happened? When x equal 4, what happened to y? Okay, when x equal 4, we have two number of y here. Y equals 6 and y equals 7. Y equals 6 and y equals 7. But at y equals 6, at point B, there is a white dot. White dot means that the value of y does not exist there. Y is defined at that point. So the value of y only exists when at the point, at the black dot, that is a point A. So the right answer is y when x equal 4, when x equal 4, when x equal 4, x sama dengan 4, y equal 7, y sama dengan 7. That uh, the value of the function. The value of the function, when we're talking about the value of a function, meaning that we are refer to we refer to topic 1. Topic 1. For topic 5, we want to find the limit of the function when x approach certain number. For the example, when x approach 4. On the left, what happened to y? Y will approach, you can see here, when x approach 4, y will close to this point. Not at that point. Y will close to the point, meaning that y will approach 6, not 7. Because now we are talking about the value. What happened to y when x approach certain number? When x approach 4, y in this case will approach 6. That when x comes from the left. When we choose any value of x less than less than 4, not equal 4, less than 4, but close to 4. In other words, we can say when x approach 4, when the value of x approach 4, close to 4, 4 on the left, maybe 3.9, 3.9999, 3.99999. It doesn't matter as long as the number is close to 4. What happened to y? We need to move. We need to find a point along this line. Okay, when we substitute x, which is the value of x close to 4, in the equation, we can see that the value of y will again close to 6. The value of y close to 6, this number, not 7, because the 7 is the value of y. Now we're talking about the value approached by y when x approach 4. So in this case, we can see that the limit of the function is 7 when x, the limit of the function is 6 when x approach 4. It doesn't matter if it comes from the left or come from the right. Okay, that's why we have two different meaning here, two different concept here. The limit and also the second one is about the value of the function. Basically, there is a difference between the value of y and the limit of y. So in other words, we can say that the value of the function, the limit is not necessarily the same as the actual value of the function at that specific point. So so in other words, when we find a limit, it's not necessary to get the same answer when we want to find the value of x, the value of y when x equal to specific number. Okay, that's the basic concept of the limit when we're talking about the limit. So the next question is how to find the limit. Okay, how to find the limit. Okay, there is if you refer to page 4 here, there is a few example, but I will explain in general. I hope you can refer page 3, page 4. Page 3, page 4, that's about the example about a rule of limit, the concept of the limit, the rule of the limit. Okay, basically, when we want to find a limit, when we want to find a limit of function, first, the first step. Okay, but I will refer to section 5.2. We want to find a limit. How to find the limit? There are two ways to find the limit. The first method is we just replace the value of x in a function. That comes from the section 5.2, the rule of limit. For example, let's say I will take let's say I have one example here. Let's say the value, okay, any value, let's say I just you can give, for example, 5.5. I have this function in general, y equal to x squared minus x, x squared plus x. Let's say this quadratic. Now I would like to find the limit of this function, the limit when x approach 3 for this function x squared plus x. Okay, how to find the limit? If you refer to the page 1 and page 2, I show you how to explain the limit based on the table or based on the graph. If that's the basic concept of the limit. But based on the rule of limit, what we can do here is, okay, we can check the limit by using the same method to find the value of x. The value of x. In other words, we can say that the first method we just find the limit as we can apply the method of find the value of y in order to find the limit. For example, based on topic 1, if we want to find the limit, so we can apply the concept of value of y. For example, what is the value of y? The value of the function. The value of y, we just substitute the value of x in the function, and then we calculate, and then we can find we get the number, the value of y. For example, when x equal 3, what happened to y? We just substitute y equal 3 to the power of 2 plus 3. There is 9 plus 3 equal 10. This is the value of y, the value of function, the value of y. This concept is this concept we learn this concept in topic 1. I explained this concept in topic 1. That is the value of y. But in order to find the limit, as we need to find the value that approached by the value approached by y when x approach 3, for example. When x approach 3. Okay, based on the previous section, I show you we need to identify the x, in this case x approach 3, and then we need to find the limit from the left and from the right. Or we must draw a graph, and for the graph we can identify the limit. But based on this rule of limit, based on the rule of limit, the limit of the function can be calculated. We can find the limit of the function by apply the concept of value of the function. You just apply the concept of the value of the function. In other words, okay, the first step, if we want to to find the limit, the first step we just I think it's better for us to apply the concept first. Now and then we check whether we can get the answer or not. So for this example, let's say we need to find the limit when x approach 3 for the function x2 plus x. What we should do here, we just substitute x equal 3 into the equation. 3 squared plus 3. The answer is 6 plus 3, also 9. So the limit from here, since we have this number, we can calculate this number. We have this number. What does it mean? That is the answer. So we can conclude here the limit when x approach 3 for the function x2 plus x is 9, because this concept, this method or this rule of when we base on the rule of limit, the rule of limit allow us to find the limit by using the concept the concept of the same method when we want to find the value of y. Okay, for this, from this example, when we substitute x equal 3 in the equation, we get the answer. The answer is 9. 9 is also the answer for the limit. This answer is of course equal to the value of y. For the value of y. So it's not 6, right? It's not 6. 6 plus 3, 9. So 9 plus 3 is 12. Okay, the answer is 12, not 6. I mistake. Okay, now we get the same answer when we find the limit and the value of y. Okay, that now in this case, we can find the limit. That is the first method. We just substitute the number. But if you want, if we substitute this number and then there is no answer for the limit. Okay, for example, let's say I have this limit. The limit 1 over x when x approach 0. When x approach 0. Based on the rule of limit, we can substitute x equals 0 in the question. Y 1 divided by 0, the answer is undefined. We cannot get the number, the limit from this case. Okay, now in this case, undefined is not the answer. We need to refer back to the concept of limit. We need to choose any number when x equal approach 0 from the right and from the left. In other words, that is not the answer. We need maybe to draw the graph and to find to set to find the value of x that approach from when x approach 0 from the left on or from the left or from the right, and then we need to determine the limit manually one by one. As I explained it. In other words, in this case, we have to find the limit manually. In other words, we need to set the value of x. We need to maybe to choose 3 value that less than 0 or 3 value is greater than 0. Okay, in the next section, I will show you what happened, what we should do when we find, in this case, in other words, when the rule of limit cannot be applied, when we want to find when we want to we want to determine the limit. That's the limitation of the rule of limit. In other words, the rule of limit, what is the rule of limit? The rule of limit tell us that in order to find the limit, we can just substitute x in the question and then check whether there is the answer, there is the value of y. If there is the answer, so the answer is also equal to the value of y. Or if there is no answer, or we cannot get any answer, maybe the answer is undefined. So we need to apply the original method of the limit, which is we need to choose any number less than 0 or greater than 0 is subject to the value that approached by x. Okay, in the next session, I will show you detail how to find the limit in this case, in this situation. Okay, let's say we have another example. I have this function. We have the quotient, the rational function. Let's say x divided by 4x minus 1. We need to find the limit the function when x approach, let's say for example, x approach 2. What we should do is we just substitute x equal to in this question. These are based on the rule of limit. 2 squared plus 1 divided by 4 times 2 minus 1. Okay, the answer is 4 plus 1 is 5. 4 times 2, 8 minus 1 is 7. The answer is 5 over 7. That is the answer, because we get the number we get the specific number. So in this case, we can conclude that the limit is 5/7, or we can find the limit based on this rule of limit. In other words, no need to determine the value of x before 2 and after 2. Or in other words, it's no need to decide to find the right hand limit and left hand limit for this example. Okay, that's about the rule of limit. In other words, in conclusion, we can say that in order to find the limit, the first step is we just substitute x into the equation, and then we decide what is the what is the limit. Okay. Any questions so far? Any question? Or can I proceed to section 5.3? Please respond. Can I proceed?
Yes,
All right.
doctor.
Any question?
No, doctor.
No question, doctor.
Okay, thank you. Okay, the next section is about the one-sided limit and the existence of limit. Okay, one-sided limit is referred to the right-hand limit and left-hand limit. As I have mentioned earlier, when x approach 2, we need to find the value of x when x approach 2 from the left and from the left, from the left and from the right. Okay, actually we can the right hand limit and left hand limit is related to the one-sided limit. Okay, basically in evaluate the limit of function when x approach a point of a, for example the point a, we can test at any point the value of y can be approached from the point from the two different directions. That is, from the right limit, we call it right hand limit, and then for the left, we call it the left hand limit. Okay, basically there are two limits before we can conclude whether the function is have as a limit or not, or don't have the limit. We need to identify the right hand limit and the left hand limit. Okay, what is the right hand limit? Right hand limit refer to the x approach a from the value greater than a. When x approach 2, right hand limit meaning that x approach 2 from the value of greater than 2, for example. And then we can write and then the notation for the right hand limit is we just put here this plus sign here, x approach a plus. Okay, this plus show that x approach a from the left, sorry, from the right, from the value of greater than a. The value of x is greater than a. That the right hand limit. For left hand limit, the value of x approach a from the the value of x approach a from the left of a, for the value of smaller than a. Okay, we call it that is the left hand limit of the function, and the left hand limit can be written as follow. We just write limit x approach a. Now we add the sign negative to the power of negative a, negative meaning that we find the left hand limit when x approach a from the left, from the value less than a. So now so in this case, in this section, we can conclude that for any limit, basically they are right hand limit. They must be a right hand limit and left hand limit. In other words, we need to check whether the right hand limit exists or not, and same to the left hand limit. We need to check the existence of the left hand limit. And then in conclusion, okay, because we have these two type of limit, right hand limit and the left hand limit, we can conclude here that a limit of the function exists only if the left hand limit and the right hand limit are equal. In other words, the value of limit for the the value of the right hand limit equal to the value of the left hand limit. The value of the limit of the function when x on the left equal to the value of the limit when x from the right. The both limit, the right hand limit and the left hand limit are the same. They have a same limit, number of the value of the left hand limit equal to the value of right hand limit, or we can write like this notation. The value of the right hand limit a plus the value of the limit of the fx when x approach a on the right equal to the value of x to equal to the value of the limit when x approach a from the left. So we can conclude that the limit of the function exists when x approach a. It doesn't matter when x approach a for the left or for the right, the answer is equal. So and then the left hand limit, the one-sided limit exists. So we can conclude that the limit is when x approach a is L or exists. That the condition for the existence of the limit is depend on whether the limit exists or not. We need to find the right hand limit and so the left hand limit. Okay. Okay. There is example 5.9, 5.10, and 5.11 here. How to describe the left hand limit and right hand limit. Okay, there is I think I will explain example the example 5.11. I hope you can do your revision on another example. Okay, let's say please refer to example 5.11. Find the limit for the following function when x approach to. When x approach to. The limit of the function, there is a limit. There is it's not hard in bahasa Melayu. Right, LIM limit. Okay, now how to find this limit? We have this type of function. We call it this a structural function. This function there's one function here, but this function has three forms: the quadratic, constant, and also linear. How to read this function? The function says that the function fx equal to 2. The function fx equal to if this is jika bahasa if x less than 2. If the value of x less than 2, the function fx equal to quadratic x2. But when x equal to what happened to the function? The value of function is 2. And then when if x greater than 2, 2.1 and blah 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 until infinity, the function change to the linear 4 minus x. When we draw this graph, we can draw this graph like this. Please refer to this page. As you can see here, when x less than 2, this area is x less than 2. X less than 2, this area. What happened? What is the shape of the fx? Fx equal to x squared. I hope you still remember this quadratic function. The value of the function is fx now equal to x squared. That's a quadratic. But when x equal to, when the value of y automatically equal to. That's why at that point, there is one black dot here. One black dot here to show that the value of y exists at that point when x equal to. When x equal to. That when x equal to okay. But when x greater than 2, the function turns to a linear equation. When x this area, you can see this area, when x greater than 2, what happened to the function? The function equal to the linear function, like this one. This area, this function is 4 minus x. Actually, there's a linear function, but this function only exists when x greater than 2. The 4 minus x, the function of 4 minus x does not exist when x less than 2. Because when x less than 2, the function changed to the x squared. The function changed from the linear to the quadratic. But when x equal to, the function also equal to. That is the difference between the between the fx. There is a different shape of fx subject to the value of y. Now we need to find the right hand limit. How to find the right hand limit? For example, the limit of the function when x approach 2 from the left, sorry, from the right, from the value of for the value of when the value from the value of when x we need to choose the value of x is greater than 2. When x approach x from the value slightly larger than 2, maybe 2.1, 2.01, 2.001. So when we refer to this graph, okay, the area when x approach 2 from the left, sorry, from the right, from the value x approach from the right 2, from the value of x is greater than 2 but close to 2, what happened to the function? The function will follow the 4 minus x. In the function is linear, so we can identify here when x approach 2, the value of y will close to, you can see here, we close to 3. That's why the answer is 3. When x approach 2 from the left, the function 4 minus what is the function? 4 minus 8. 4 minus 8 when x approach 2 from the right. 4 minus 2, I think it's some mistaken here. I will check this function because there is a 4 minus when x approach 2 or when x approach 1. Okay. Wait a minute. I need to check this function first. One, two. Okay. I think there is a mistake here. Okay, there is a not 2. This not. Okay. Please correct your note. There's not 2 when x. That's why I think there is something wrong here. There's not 2. There's 1. 1. Okay, there is 1. When x approach 1, please let's do this correction. When x approach 1, not 2. Okay. When x approach 1 from the right, from the right. When x approach 1 from the right, meaning that x approach one from the values is slightly larger than 1, maybe 1.1, 1.001, and so on. We use the part of the function when x uh, when x greater than 1. That is the limit of the function 4 minus 1. Just we can follow the rule of the limit 4 minus 1, and then 4 minus 1. The answer is 3. So if we refer to the graph, when x approach 1 from the left, from the right, the value of y will approach 3. That is the correct answer. There's a mistake in my lecture note. Please correct. We just change the value of x equal 1 instead of 2. And then for the left hand limit, as you can see here, the left hand limit refer to the situation when x approach 1 from the left, for the value slightly smaller than 1, maybe 0.9 or 0.999, 0.9 or 0.999, for example. Okay, for this case, we need to use the part of the function when the value where x less than 1. That is the quadratic part of the function. So when x approach 1 from the left, we apply the x squared. So the value of when x approach 1 from the left, we need to apply the quadratic part. So the answer, when x approach 1, we just substitute x equal 1 in the equation. The answer is 1. There is also some mistake here. Please correct this. When x approach 1. So the answer is 1. The answer is 1. So now we have the left hand limit and right hand limit of the function for fx. As you can see here, the left hand limit of the function is 1. The right hand limit of the function is 3. So in other words, we can based on the finding, we can conclude here the right hand limit does not equal the left hand limit, or we can write like this: the limit of the function when x approach 1 from the left, from the right, does not equal when x approach 1 from the left. So in other words, we can say that the limit of the function when x approach 1, in general, we can say that the limit of the function when x approach 1 does not exist. When x approach 1 does not exist. There is no limit when the function approach 1, because the right hand limit does not equal to the left hand limit. Okay, that's about the one of the example about the limit. The left hand limit and the right hand limit. So if the value of the right hand limit does not equal to the left hand limit, the conclusion is the limit does not exist. In other words, when these values are equal, the left hand limit equal to the right hand limit, the value of the limit are equal, we can conclude that the limit exists when x approach that number. Okay, that is from the example 5.1. Okay, you can I hope you can review another example in order to improve your understanding about the right hand limit and the left hand limit. Okay, the next one is about the situation when we cannot apply the rule of limit. How to find the limit when we cannot apply the rule. In other words, when we are unable to find the limit based on the rule of limit, we need to apply the original, the theoretical of the limit. In other words, we need to choose any number, maybe 2 or 3 number before and after that the value of A, and then we can check whether the limit is exist or does not exist. Okay, the form. Okay, before I continue to this section 5.4, I think we take a break for 10 minutes, and then we will continue on section 5.4. Can we take a break?
Yes, doctor.
Okay, we take a break for 10 minutes only, and then we continue at section 5.4. Okay, can we continue? Can we proceed?
Yes.
Okay, thank you. Okay, the next section is about the infinite limit. Limit tidak terhingga. Infinite limit or had tidak terhingga. Okay, infinite limit occur when the fx, the value of y, increase or decrease without bound as x approach a point. So in other words, we can say that if the value of x, if the value of x increase infinitely when x approach a number, then we can say we can write that x then the value of fx limit x approach a for fx is equal to positive infinity. Okay, in this case, we can conclude there is no limit, or the limit of the function does not exist. Okay, the second situation is the value of fx decrease infinitely when x approach the number. The value of fx, the limit of the function when x approach a is equal to negative infinity. Also, in this case, we can conclude that there is also no limit to the function. For example, let's say we have this function y equal to 1 over x squared. Y equal to 1 over x squared. Now we need to find the limit of the function when x approach 0. Based on the rule of limit, if we substitute this value x, when x, we just substitute x equals 0 into the function, we can find the answer is undefined. We cannot find the limit when we follow the rule of limit, which is we just substitute the value of limit into the equation. 1 divided by 0 is undefined, or math error. When you use your calculator, you get the answer is error, or in mathematics this refer to the undefined. The value of y is undefined, tidak dapat ditentukan, tidak dapat dikenalpasti, or nilai y tidak wujud when x approach 0. So in this case, we need to back to the real concept of limit, which is we need to find the value of x. Maybe you need to choose any value, three value of x that is less than 0 or greater than 0. You can choose any value. For example, if based on this table, I can choose the value from 1 to 0.001, or from -1 to the -0.001. If we replace this all value to the function, we get the value of y will the value of y is will increase infinitely when x approach 0, whether from the left or from the right, based on the graph or this table. Okay, in this case, we can say that the right hand limit is infinity, the left hand limit is also infinity. In this case, this infinity show that the value of x, the value of fx increase indefinitely when the value of x, when x approach 0, whether for the left or for the right. So we can conclude that there is no limit because the value of the function become larger when x close to 0. So the limit does not exist at point x equals 0. And this is the case when there is the infinite limit. There is no limit. The value of x increase or decrease infinitely. Same goes to the example 5.13 for line 1 over x, y equal to 1 over x. When x approach 0, based on the rule of limit, we can substitute this x equals 0 into the equation. 1 divided by 0, the answer is undefined. The answer is undefined. So, in other words, uh, we need to identify, let's say, any number, whether the number must be less than 0 or greater than 0, but close to 0. Let's say I choose these three number, negative 0.01, positive 0.01, negative 0.001. I just substitute. All this number in the equation 1 over x. The answer is, as you can see here, the value of y decrease indefinitely. In this case, is when x approach 0 from the left. But when x approach 0 from the right, I choose these three number, x 0.01, x 0.001, x 0.0001. Substitute these three number in that equation. We can see that the value of y 1 over x will increase indefinitely. So the left hand limit increase indefinitely. The right hand limit decrease uh, decrease indefinitely. So in other words, we can write that like this notation here. The value of the limit of the function, the limit of 1 over x when x approaches 0 from the right is positive infinity. The limit of 1 over x when x approaches 0 from the right, from the left is negative infinity. In this case, we can conclude that there is also no limit. There is also no limit for the function, because the value of y increase or decrease indefinitely when x approach 0. Okay, when we draw this graph, we can draw this graph, this function 1 over x. Okay, this graph show clearly that there is a y. This function is belong to y over 1, y equal 1 over x, 1 over x, sorry, 1 over x only. Y equal 1 over x. What happened to the function? When x approach 0 from the left, from the right, the value of y will approach infinity, positive infinity, increase indefinitely. But when the value of y, when x approach 0 from the right, from the left, what happened to y? The value of y decrease indefinitely. The value of y approach negative infinity. So we can conclude here. Therefore, in this case, limit does not exist when x approach 0 for this case. Okay. When one on the limit increase or decrease definitely, the conclusion is the limit does not exist. Okay, that the concept of limit at infinity. The next one is a limit at infinity. Had pada ketidakterhinggaan. What does it mean? Limit at infinity refer to the situation where we want to determine the value approached by fx as x increase or decrease without bound, or x increase indefinitely or increase definitely or decrease definitely. When x approach infinity or when x approach negative infinity, what happened to x? What happened to x? That limit at infinity. Okay, for example, for 1 over x. Okay, this function y equal to 1 over x. Now I choose when x approach positive infinity. The value of x increase. Let's say for 1,000 to 10,000, 100,000, and 1 million. What happened to y? 1 over 1 number divided by the larger numbers. The value of the whole function now decrease. As you can see, the value of y, the value of 1 over x, we close to 0. So in this case, when x increase indefinitely, the value of y is getting closer to 0. So we can write like this. The limit of the function 1 over x when x approach infinity equal 0. Okay. The next one, when x, the value of x decrease. The value of x, the value of x, the value of x decrease. In this case, when x, I choose 3 value of x, 4 value of x, which is the value of x decrease from negative 1,000 to negative 1 million, for example, as you can see here, the value of y will also decrease. It also decrease and close to zero. So from this example, we can conclude that when x decrease indefinitely, the value of x will approach zero. The right hand limit is zero, and also the left hand limit is zero. But the value of y, the value of x, increase or decrease indefinitely. In this case, the value of y will approach zero, whether x approach negative infinity or positive infinity. Okay, that's the value limit at infinity. In other words, we need to find the limit when x increase or decrease indefinitely, when x approach infinity or when x approach negative infinity. Okay, that's about the limit at infinity. There are two different concepts: limit at infinity, and the first one is an infinite limit. I hope you can differentiate between these two concepts: infinite limit and limit at infinity. Okay, that's the what we call it, the concept that you need to know about the limit. The first part of this chapter. Okay, the last one for today is about the limit for indeterminate form. In order to when we want to find the limit, please remember basically how to find the limit. We just based on the rule of limit, we just substitute the value of x into the question and then find the limit. If we can find the answer, that is the answer, and then we can stop. So, but if we cannot find the answer, when we apply the rule of limit, we cannot find the answer. Maybe the answer is undefinite, 0 and 0, and so on. We need to adjust. We need to apply back the real concept of limit. In other words, we need to find the we need to choose a few value of certain value of x. Maybe the value of x, maybe you can choose 3 or 4, 5 value of x that greater than a, but close to a. And then the second one, you need to identify the left hand limit, which is the just choose 3 or 4 value of x, 3 or 4 value of less than x, less than a, but close to a. And in other words, we need to identify the left hand limit and right hand limit by using the concept of limit. But in section 5.6, there are two cases here. When we want to find the limit, sometimes we will find this case. The first case is infinity divided by infinity. We get this number. The second one is 0 divided by 0. Okay. In this situation, we can simplify the equation, but we must follow the concept that is determined by this method. Okay. Okay. In general, we can say that an indeterminate form occur when evaluating a limit result in an expression that does not provide enough information to determine the actual limit. There are two primary cases here. That this case will be discussed in this part. The first case is the rational function at infinity. In other words, when we see this situation, infinity divided by infinity, or negative infinity divided by negative infinity. When calculating the limit as x approach infinity, especially, or when x approach negative infinity for a rational function. Rational function refer to the ratio a divided by b. We have a numerator and the denominator. You may encounter the form 0 divided by 0. Okay, to solve this, you can simplify the calculation by focusing on only on the term with the higher power in the numerator and denominator. Okay, that is the method that we can apply for this case, infinity divided by infinity. For example, Okay, for example, example 5.1c, I share with you the step by step how to solve this situation. Let's say we have this function, this rational function, this ratio function, 3x squared minus x 6x plus 3 divided by 4x to the power of 3 minus 6. Now we need to find the limit when x approach infinity. The first one is we identify the intermediate form. How? We just substitute infinity into the function. Both the numerator and the denominator, the bottom part, increase without bound. This result in the intermediate form, the infinity divided by infinity. This show that we cannot determine the limit by just looking at it. We need to simplify the expression. So what does it mean? When we substitute infinity in this function, we get 3 infinity to the power of 3 times infinity squared minus 6 times infinity plus 3. The answer is infinity. 4 times infinity to the power of 3 minus 6. The answer is also infinity. That's why we have infinity divided by infinity form. So for this situation, what we can do, we just need to apply the highest power rule. What does it mean? The highest power rule is to simplify a limit at infinity. In order to simplify the limit, we just look for the term with the highest power of x. We just choose the term with the highest power of f in both the numerator and denominator. In the numerator, we know that there is a 3x squared minus 6x plus 3. The highest power term is 3x squared. Now we choose this term. In the numerator, the highest power term is 3x squared. But in the denominator, the highest power term is 4x to the power of 3. Okay, because at the first place, we get the form infinite by infinite. So how to solve this problem? We just choose the highest powers in numerator and denominator. The highest power for numerator, the highest power is 3x squared. For denominator, the bottom part of the equation is the highest power is 4x to the power of 3. Now we take this ratio of these two terms. So we can simplify. For this equation, we just take the 3x squared for numerator divided by 4x to the power of 3 for the denominator. We can simplify this equation. So now our limit equation becomes to the limit of 3x squared divided by 4x to the power of 3 when x approach infinity. This equation we can simplify. We can just slash this equality divided by 4x. So now we have the limit of the function when x approach infinity. 3 divided by 4 times infinity equal infinity. So 3 times infinity, the answer is 0. 3 divided by any number. Yeah, 3 divided by the larger number, we close to the answer is 0. Now we can conclude here that as x approach infinity, in the simplified term 3 divided by 4x, the denominator become infinitely large. Any constant, as I said earlier, divided by any infinitely large number will approach 0. So in conclusion, we can say that the limit of the function as x approach 0 is 0. Actually, as x approach infinity is 0. This indicates that as x get larger and larger, the value of the entire function get closer and closer to 0. Then how to find the limit in this case? Okay, this step is only valid. Is only we can apply this concept when we get this form infinity divided by infinity divided by infinity. Okay, that is the step for the rational function at infinity. Okay, there is a few examples here. I hope you can review the example, and then there's an example for infinity divided by infinity. for this case, for case when x approach infinity. All this based on example 1.59, the example we have this form infinity divided by infinity, or especially for 1, 2, and 3. 4 and 5, in this case, there's no rational function. We just get the infinity. Then we still get the same. We still get the same answer. Okay, the last one for today is simplification by factoring. For case 0 divide by 0. Okay, 0 divided by 0, the answer is undefined. Same goes to the infinity divided by infinity. When a limit result in this form, 0 divided by 0, is often mean that there is a common factor in the numerator and denominator that can be cancelled out to find the actual limit. In other words, when you get this ratio, infinity divided by infinity, that's not the answer. We need to modify the equation. In this case, we need to modify by factoring the equation. By apply these two concepts here. You need to know this concept, the algebra identity, the difference of squared and perfect squared. When the form is in terms of x squared minus a squared, we can divide this, we can factorize this number, x plus a and x minus a. You need to remember this this concept. The second one is a perfect squared. X squared plus 2xa minus a squared can be factorized by in this two form, x plus a plus x plus a. Okay, this case is for when the at the first step, when we just follow the rule of limit, we find if we 0 divided by 0. In the case, we need to factorize, simplify. We need to factorize the equation. For example, let's say we have this limit. Limit when x approach -5, when for x squared minus 25 divided by x plus 5. So when we direct substitution, we just substitute x equal -5 in the equation. We get -5 squared minus 25. The answer is 0. And then for denominator, -5 plus 5 is also equal 0. Now we get this form. Okay, there's a special case. There is, of course, there is not the answer. In this case, this 0 divided by 0 indicate that we need to solve the limit by using the factor by using the by factoring the equation. Okay, based on the numerator, we have this equation. This equation is written in form of x squared minus a squared. There is this x squared minus 5 squared. This can be factorized by x plus 5 to x minus 5, like this. Factor the numerator. So now we substitute x. We just substitute this x plus 5 and x minus 5 in the equation. X plus 5 times x minus 5 divided by x plus 5. Okay, we can simplify this equation. We can simplify this equation. Now we can simplify the equation to the x minus 5 only. We can simplify the equation x minus 5 only. Okay. So now our limit, the equation now become the limit of the function when x approach -5 of x minus 5. Now the answer, we just substitute x equal to -5 to the equation. The answer is -5 divided by -5. The answer is -10. So the -10 is the real answer. The correct answer for this limit. So because in this case, this step is valid if we get this form first. Infinity divide by infinity divide by zero divide by zero divide by 0. But for question B, there is a same equation here. Same equation, squared minus 25 divided by x plus 5. But for this case, x approach negative 5. X approach positive 5. Based on the rule of limit, we just substitute x equal 5 in the equation. We get that negative 5 squared minus 25, the answer is 0. But 5 plus 5 is 10. 5 plus 5 is 10. Okay, now we get 0 divided by 10, the answer is 0. In this case, we get the answer. The limit is equal to the limit is equal to 0. So in other words, it's not necessary for us to factorize the equation, because this form is not 0 divided by 0. Just this example, just to remind you that we can apply this. We need to factorize the equation when we get this form 0 divided by 0. For example B, the form is not 0 divided by 0. The form is 0 divided by 10. So we can get the answer. The answer is 0. So no need to factorize the equation. That is the answer. We can stop here. Okay. That the situation when the two form here, the two special case. The first one, when we get this form infinite divided by infinite. Remember, infinite divided by infinite form. And then the second one, when we got the form 0 divided by 0. So when the form is infinite by divided by infinite, we just choose the highest power, the term of the highest power term in numerator, and also the highest power term in denominator. But for the second case, when the form is 0 divided by 0, we just need take the we need to factorize the equation, and just simplify the equation, and then the next we just find the limit. And then as you can see in example 5.2, we get the answer. The actual answer is not 0 divided by 0. The actual answer is negative 10. Because the form of the limit at the first place is 0 divided by 0 divided by 0. Okay. Okay, that's all for the first part of this topic. Okay, the second part, I think I will continue the second part of this topic, concept of continuity. Continuity is this concept is also close. This concept is also is related to the limit. In this continuity, we will apply the concept of limit, but I will explain this concept next week in our another online replacement class on Friday. I will decide the time, whether it's in the morning or if afternoon. I will decide later to our WhatsApp group as usual. Okay, so in other words, this concept I will continue on next week on Friday, 29 June, for a concept of continuity. Okay, I think that's all for today. Any question?
Doctor, I have a question, Doctor.
No question.
Yeah, please.
So for the midterm, right? What's the format going to be like? Is it MCQ or subjective, or is it going to be mixed?
Okay, thank you, Daniel, for the question. Okay, basically, generally, for midterm, I think for this semester, maybe there is a two part A or part B, or part A, maybe actually I will not decide. Okay, in general, I can say you can prepare for midterm. There is two part A MCQ, part B structure. Part MCQ, you have MCQ with 5 choice question. You need to choose one from 5 option. And part B maybe a few questions about the structure question. In other words, structure question mean that you need to write your answer and then to show your work. But I will that in general there is two part A and part B, and total mark is normally 100%. Then our exam will be held maybe in 2 hours, 2 hours or 2 hours and 30 minutes, depend on the number of questions. So you can prepare for the two type of questions, structure and the MCQ. Okay.
Yep. Thank you, Dr.
Any other question? Okay, welcome. Okay, if there is no question, I think that's all for today. Thank you for your attention and see you next week. Assalamualaikum and still good morning.
Wait, Doctor, the attendance is
Okay.
via Teams, right?
Yeah, by team. No need to scan. No QR code.
Yep.
You just
Okay.
wait until I end this meeting.
Yep.
Okay.
Thank you, Doctor.
If there is no question, that's all for today. See you next week. Assalamualaikum and good morning again.
Thank you, Doctor.
Thank you, Doctor. Bye.
Okay, welcome.